L107, volume and surface area of compound solids. What's our objective, class? Get ready?
Volume and surface area of compound solids.
So we've already done volume and surface area of different shapes, but we haven't done compound shapes. So what is a compound shape? So here's a compound shape. It's a shape that's made up of two other shapes. So we know how to find volume of this, length, width times height. We know how to find the volume of the pyramid. It's 1/3 area of the base times the height. So if we put them together and say, hey, what's the volume of this whole shape? You would just simply, if it helps you can draw them separate and find the volume of each and add them together. So what about a shape with circles? Okay, here's a compound shape. And these exist in our real world, right? Maybe they're in weird objects, maybe buildings or maybe other things. But here's the volume of a cylinder is area of the base times the height, pi r squared h. Volume of a cone is area of the base times height, but 1/3, right? 1/3 area of the base, so it's another pi r squared because it's a circle. So we're going to do a couple examples, one with some circles and one with not. If I was going to find the volume of this stool, it's made up of 1, 2, 3, 4 legs, but what shape is the leg in? What shape would I use? Layla? It's a cylinder, right? So my base would be the circle at the bottom, pi r squared, and then I'd have my height right there. What about the seat? What shape is that? Liesel?
There would be a circle.
Circle, but what about this thickness right there?
Right. I would say a percent maybe, or a cylinder.
It really is a cylinder. Picture it like it's a really wide cylinder, but it's like squashed. It's really flat. Okay? So I can still use my pi r squared times the height. So we're going to do a practice of this cylinder. Okay, so this is a weightlifting weight right here. It's got a diameter of 20 centimeters. It's got a thickness from here to here of 2 centimeters. So from here to here. We're going to find the volume of it, but you guys notice it's got this hole cut out in the middle. I drew right over it, but picture it's like this, right? So I could find the volume of this whole thing, but I have to do something with this space that I don't want to take the volume here. Can I pretend that this is its own little disc inside here and find the volume of that and subtract it out? We'll do that. Okay. So first let's do the big one. So we got volume of the weight. I'll use W for the weight equals area of the base times height. The area of the base is a circle, so we use pi r squared times the height, which is pi times the we need a radius. What is the radius? Addison. 10 centimeters, very good. So 10 squared times the height, which is 2. If you're okay, we're going to do this mentally real quick. So 10 squared is 100 times 2 is 200. I'm going to put that in front, 200 pi centimeters cubed. All right, now the volume of the hole, I'll call it H for hole. Let's draw that out separate. It's about that big. It's got some thickness to it. It's got a diameter. What is the diameter? The hole in the center is 2 centimeters in diameter. So it's 2 centimeters. Well, I know I'm going to need a radius. I'm thinking. So it's a cylinder. You need pi r squared h. So we go pi times radius. What is my radius? Winry?
1.
It's 1, right? It's half the diameter. So 1 squared, and my height is still 2. That's going to give us 2 times 1, which is still 2, times pi, so 2 pi. Some of you are going, Mrs. Boone, don't we need to calculate the pi in there? No. Mathematicians love to leave pi in the answer because pi is exact. I didn't have to round to any decimals in my digits, in my decimal points. So I'm going to leave it as pi. So the whole one minus the whole, we're going to subtract. 200 minus 2 is 198 pi cubic centimeters. So that's the volume. So you might, if you worked at a metal fabrication plant and said I needed 198 pi centimeters cubed of iron or lead or whatever they put in these things, you're probably not going to tell them pi in your answer if you tell them, right? You're probably going to give them a decimal. But the mathematicians, we're going to keep pi in our answer. All right, so what about the bar? Okay, find the volume of the bar. Well, it's thick and then it gets thinner. So we just said, let's just use an average thickness of 2 centimeters. Just use an average. And then the length of it, it says the length is 100. So I'm going to go like this, 100, all the way to the end. All right, so let's go with this. Volume of the bar it is area of the base times height, which is pi r squared times h. What's my radius? Okay, Holden? Connor?
1.
1, very good. Because if my diameter is 2 from here to here, then my radius is going to be half that. My height is really the length, all that whole thing. So I go 100 pi. Done. So much nicer without calculating pi, right? It's a lot easier. So in the next question, it says, what's the total volume for the barbell and both of the weights? So now we have 2 weights, which we figured out. We'll call this total. We had 198 pi, but there's 2 of them, 198 pi. And then we had the bar, which we figured out was 100 pi. We're going to add all those together. Who's got that? You that mentally? 200, 200, 100. Jasmine, you got that? Well, let's just do it mentally. 200, 200 makes 400, plus 1 is 500. Then take off those 2 and take off that 2. 496. Is that what you're going to say, Ethan?
Yeah.
Yeah, after you added the 100 on. Sweet. Okay, so 496 pi cubes are really like that. So volume's not that bad. Let's do another one without circles that's all in flat or flat surfaces. All right, so if you notice on the top of your desk, it's made of wood, but on the top of it there's a veneer. It's actually plastic. And they coat the wood with plastic that makes it waterproof, it makes it more cleanable, washable. If you're lucky to afford a hardwood desk, they don't put a veneer on them. Anyway, so why do we care about surface area and volume? So volume, see how much space can the desk hold? Surface area, how much veneer are we going to place on all of the exposed surfaces? So let's first talk about volume of this guy. How could I break this into pieces or polyhedrons, I guess, that we can take the volume of? How would you separate it out? What do you think, Winry?
We're supposed to take these 2 side cabinets and go all the way up to the very top.
Oh, you'd go up to the very top? If we did that,
Wait, we don't have dimensions for that.
it'd take a little bit more. We'd have to do this one, but we could. My other classes have done it like this. Should we do it like that? Whoops, I missed. So we just take this. So if I drew it out here, it's going to look like this. And that's the leg, and there's 2 of them. Are they the same size?
Yeah.
They don't look the same, but they are. Look at the dimensions. They're the same dimensions. Okay, so we got 2 legs, and then we have a top. The top's like this, all right? Here's our top. All right, so if we could just break out and find out, we could just go length, width, height. Find the volume real quick. Length, width, height. So let's label this in feet. That's 1.5 feet, 5 feet, 2 feet, 1.5 feet, 2.5 feet. Same thing, 2.5 feet. But you know what? This dimension goes all the way up. We're not even going to use that. This top part, we're going to do this top. But how thick is that top? How thick is that, Ethan?
6 inches.
How do you get that?
Because the 30 minus the 24 of the height of the legs.
Right here. The whole length is 30, just this much is 24, so it's got to be 6. All right, let's change it to feet, so it's 0.5 feet. All right, so this one's 0.5, 2.5. 5, get your calculators ready. This one is 2, 2.5, 1.5. All right, volume of the legs, length times width times height, length, width, height. Who's got that calculated? Aubrey?
7.5.
Sweet. I love that you are fast and ready to go. Volume of the top, length, width, height. Who's got that? Colin?
2.25.
It looks a little small.
22.
Looks a little big. Ethan, what'd you got?
I got 6.25.
That sounds right. Check it one more time. You're going to go 5 feet across,
Yeah.
2.5 feet wide, and this is a 0.5 right there.
Yeah.
Okay. So to get the total volume, we just have to do 2 legs plus our top. So we're going to go volume total equals 2 legs plus the top. Who's got that?
1.25.
Perfect. Alright. Okay, question. We're going to talk surface area now. Kaylee.
If you calculated the volume first and then you divided it by 12, does that still work to get feet to convert the inches?
Okay. Almost. If you're going to convert inches to feet, you would divide by 12 inches, right?
Yeah.
Okay, so you'd have feet on top, 1 foot, 12. But if you're doing cubic inches into cubic feet, and that's why we converted first, you could, but you'd have to do 3 converters, and you'd have to go inch, 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 feet, feet, feet. So you'd be going 12, 12, 12, which is a really big number. And I think that's why the book wanted you to change it into feet before calculating. Okay. Lexi.
What's the volume for a cylinder, the equation?
It's be pi r squared times h. Okay, great question. Okay, surface area. I want to talk about surface real quick. Let's say this is my polyhedron, and it's sitting. Let me come in front so I'm on the camera. If it's sitting on a surface, what is the exposed surface area? What does the word mean, exposed? Well, I mean, if I'm walking around, what are the spaces that I can see? And if I'm a bird and flying, what do I see? Well, I see this face, this face, this face, and this face, and this face. I don't see the bottom one, okay? Because that's flat on the ground. Likewise, if I cover the top one up, it's got another surface on it. What are the exposed surfaces? 1, 2, 3, and 4. There's only 4, right? So if I told you this was 1 square centimeter, this is blown up, right? 1 square centimeter. The exposed surfaces are 1, 2, 3, 4 square centimeters. If I took this off, now I have 5 square centimeters. So that's my exposed surface area. So if it says don't exclude, or it says exclude the base, they're talking don't talk about that one. You can't see it. All right. So if I were looking at surface area of this, could I just break up and come in red? Could I find the area of this face, not this one because I can't see it. I can times this one by 2 and times because I've got a front and a back, right side, left side, and I have 2 of like that. I see this face, I see this face, I see this face, and I see the side face, but there's one more surface that I haven't drawn. Connor?
The back.
Like behind it?
Yeah.
Like that line behind it? Okay, so that's like, let's do a dotted, so that's behind there, so I definitely need that one. There's one more. Monica?
Small section where the legs touch the.
Yep, right there. Okay, so, oops, that's in the front. You guys see that under, so if I was sitting in here and I looked up, that's an exposed surface area. I would have to count that in. So, how wide is that surface area right there? I know the depth is 2.5. How far back it goes. How wide is that? If you think you know, raise your hand. I just want to see who's thinking. Who's calculating? I got Layla, Samantha, Jasmine, Emmy, Emma, Spencer, Winry, Kaylee. More hands are going up. You're seeing it. Jasmine, what do you got?
I got 34. Not 34, sorry, 24.
Inches or feet?
Oh, that would be inches.
Inches. She's right. I'm gonna put her answer into feet. She's right because 1.5 is 3, and the whole thing is 5. So subtract 3 from 5. So very good. Okay. So if we want to find surface area, we could do it, right? We're not gonna, but we could. For your practice set today. Not yet. Hold on a second. Actually, yes. You get